All right, our lesson for 2.5, we're going to get into a whole bunch of theorems that we call properties here in the next couple of days that we will be using for the rest of this year. So these ones coming up are pretty important. Today, we're going to focus on the addition and subtraction properties. Now, this is a little bit different than just plain old addition and subtraction that we use with algebra, but concept is the same, but the way we use them in proofs and things might be a little bit different. So that's what we're going to focus on, just addition and subtraction today. So our warm-up here is going to do some more of these drawing conclusions from pictures. So hopefully you're getting to be very confident doing this, but these are just a great way to get your mind moving and really get you into the mindset that we're going to be needing for you today. So if you haven't taken a shot at these two warm-ups, written down as many conclusions as you can based off of the given information, then why don't you pause the video now and go ahead and do those warm-ups. So my first one over on the left says I have the diagram as shown there, right? So I've got this big long segment. It's split into some different segments, A, B, B, C, C, D, and I actually have some measurements given, right? So hopefully you started thinking like, okay, well, I can see that AB is congruent to CD. Like that's probably one of the conclusions that you wrote down because they have the same measure, right? AB congruent to CD. Sure. All right. Well, maybe we could go a step farther than that though. What if we started combining? Like what if I said like segment AC? AC would be 10 centimeters, right? And then what about maybe segment BD? Well, that would be 10 centimeters, wouldn't it? Oh, but then that means that segment AC would be congruent to segment BD, and that wasn't something that was necessarily very obvious in the picture to start with, right? The 7 centimeters and the 7 centimeters hopefully jumped out at you, and you had AB congruent to CD in your list somewhere, right? But then maybe starting to combine some things, and then we've got a more surprising conclusion than what was exactly obvious to start with. So in that case, I had two congruent segments, and I added the same segment to both of them, right? I added this little guy BC to both of them, and I ended up with two bigger congruent segments. Okay, how about over on the right here? So over on the right, we are given that angle ABE is congruent to angle CBD. So these two angles here were congruent. Now we weren't given any angle measures at all. So on the last one, some things jumped out at me because I had some numbers, right? But maybe if you were getting a little stuck on this one, maybe now that you saw the last one, this one might be doable. If you need to, you can pause now and see what you can do on this one. So if I look at this, and the last one I started combining some things, right? Well, what if I combine two angles here? What if I get angle, say, EBC? And what if I combine, let me get a color here, sorry, and I get angle ABD. So in both of those, I started with two congruent angles, and then I added this middle angle to both of them, right? So if I said that this was 5 degrees and this was 5 degrees and that middle part in there was 20 degrees, well then I would have 25 degrees and 25 degrees, right? But I don't even need all those numbers. You can just kind of think of it, well, if I'm adding that same exact angle to two congruent angles, then those sums, the bigger ones must be congruent as well, right? So angle ABD would be congruent to angle EBC. All right, well, this just kind of got your brain trying to see some different ways of looking at pictures here by combining things that wouldn't have necessarily been things that you would think to combine to start with. But in fact, as you did those, you also learned the addition property. So our first theorem of today, our first property, is the addition property. So if I have the same segment added to two congruent segments, now it is important that you know your two segments are congruent, or angles, right? Then the sums are congruent. So if the same angle is added to two congruent angles, then the sums are congruent. Now think about that, right? If the 7 centimeters was not the same, if I had a 7 centimeters and 8 centimeters, then that wouldn't have worked, right? All right, so the same segment added to two congruent segments, then the sums are congruent. Or the same angle added to two congruent angles, then the sums are congruent. And we had to make sure that we had two congruent things that we were adding that same one to. But that's our first addition property. Pretty cool, right? Okay, so the next example here, a little bit more drawing conclusions. This time you are given angle XWY is congruent to angle LQP. XWY, this guy, oops, congruent to angle LQP. So this one over here, that was our first given. And then we have angle ZWY congruent to angle NQP, these ones over here. All right, pause the video and see what you can conclude there. Okay, now hopefully it jumped out at you as like, well, if I have these two congruent parts, no matter what the measure is, if I'm adding them, then these two are also congruent to the same ones. Boy, those bigger ones have to be congruent, right? If you're having a little trouble, think of it as like, if I said that this was 60, then this would be 60, right? If I said this was 20, oops, then this would be 20, right? And so then the whole big angles would be 80 and 80, and those would be congruent as well. So my conclusion would be angle XWZ is congruent, and I'm going to run out of room here, sorry. Angle XWZ is congruent to angle LQN, right? Now be careful that you don't write any conclusions that we have right angles here. There was no measurements given. I made those up, but even with the ones that I made up, I did that on purpose so that you wouldn't jump to that conclusion that I have 90-degree angles there. That's not something you know with those givens. Only that the bigger parts would be congruent. Now the question is that exactly the same as the addition properties we just learned? If the same angle is added to two congruent angles? Hopefully this is a ringing a bell from your supplementary and complementary theorems. This is almost the same, but not quite. It's a little bit different. So this one we have, if two congruent angles or segments are added to two congruent angles or segments, then the sums are congruent. So the first set of addition properties that I showed you, we were adding the same angle or segment, right? And in this second set, I'm adding two congruent to two congruent. So just like in those complementary and supplementary theorems, really take a look. How many things are you talking about? Notice in these first two are warm-ups. I had 3 things that I was combining, right? I combined 2, but I only had 3 total. 1, 2, 3 segments. 1, 2, 3 angles, right? But in that, so that's where I had the same angle or segment added to the two congruent. In this second set, I had 1, 2, 3, 4 total things that I was combining. So be careful that you know which one is which and which one you're using. But there we have some addition properties, right? Okay, how about another drawing conclusions example? Here I am given AC is congruent to BD. So this looks very similar to that first problem I gave you in the warm-up. But this time you're given that these two big parts are congruent. What could you conclude? Hopefully you're in the zone now with our drawing conclusions and you are recognizing, oh, well, if the big parts are congruent and I take away this segment BC from both of them, then that means that these smaller parts must be congruent as well. So AB would be congruent to CD. But this wasn't addition, was it? I had big parts. I was taking away the same thing, and I ended up with little parts being congruent. When I'm taking away, haha, this is the subtraction property. So in this example that I showed you, the same segment is subtracted from two congruent segments, then the differences are congruent. So remember, the answer when I have a subtraction problem is the differences. So that's why I'm using good vocabulary here. So the same segment subtracted from two congruent segments, then the differences are congruent. And that would also have worked for angles. Notice I didn't write the whole theorem out again for you this time, saving a little space. You can save space as well. We could swap that word segment out for angle if we need to. Well, I'm sure that you guys are really catching on now, so you know that if it works for the same segment or angle being subtracted, then it would also work for two congruent segments or angles being subtracted from two congruent segments or angles. So we have two different versions of the subtraction property as well. Now, just to get you used to it, why don't you take a look at this one and see if you can figure this out now that you have those addition and subtraction properties under your belt. So here we're given that KW is congruent to KP. So this big part over here, congruent to this big part over here. We're given that NW is congruent to RP. What else could we conclude? Big parts congruent, two congruent small parts. If two congruent segments are subtracted from two congruent segments, then the differences are congruent. So KN is congruent to KR, and that would be that second subtraction property that we just saw, that bottom one right there. All right, so hopefully this idea of the drawing conclusions is getting to be really helpful for you. So we've gone through all of our addition and subtraction properties. So we have two versions of each one, right? And obviously we can use segments or angles for each one. So first we have, if the same segment or angle is added to two congruent segments or angles, then the sums are congruent. If we have two congruent segments or angles are added to two congruent segments or angles, then the sums are congruent. Then we have the subtraction ones, right? Same segment subtracted from two congruent segments, the differences are congruent, or two congruent segments subtracted from two congruent segments, and the differences are congruent. And we have pictures that go along with each. So you need to make sure that you understand, when am I going to be using addition and when am I going to be using subtraction, right? So hopefully your math brain helps you kind of logic that one out, but I wrote it up here. We didn't focus on it till right now on purpose. But up here at the top, it says that addition property is used when segments or angles in the conclusion are greater than those in the given. Okay, so if things are getting bigger, you need to be using addition property. I wrote it here as well, just so that you have it. Addition property, if the conclusions are greater than the givens, right? And then if I'm using subtraction property is used when the segments or angles in the conclusion are smaller than those in the given information. Okay, so if you're going from bigger to smaller, it's subtraction. If you're going from smaller to bigger, it's addition. These wouldn't be terrible ideas to put on some flashcards for you. You know, you have a picture right here that could go with, and you could flip them over and have the good if-then form on the back with the correct property. This is a good time to make it. Maybe we'll take some time to do that soon, but if you want to get started, this would be a really good chance to do that, because it's easy to get them confused. All right, so now that we have all of our properties, why don't we go ahead and see if we could write a proof, okay? So in this proof, I have that segment AB is congruent to CD, and I'm trying to prove AC is congruent to BD. I will give you a hint. This is not a long proof by any means. The trick of it is to make sure that you understand which property to use, all right? Pause and see if you can do it. Okay, so if I look at this, my given, step 1, AB is congruent to CD given. All right, I'm trying to prove that AC is congruent to BD. This is what I'm trying to prove. See how when I highlighted it, it really helped it jump out? So A, B, and CD, my givens, those were small. What I'm trying to prove is bigger, right? I'm going from little parts to big parts. So that must be the addition property. And in fact, I can go straight to my prove statement right now. Segment AC is congruent to segment BD. So it's definitely the addition property. Now, am I adding the same exact segment to both, or am I adding two congruent segments? Well, if I look at that, how many total segments am I talking about? 1, 2, 3. The two that I know congruent and the one that's in the middle that I'm going to add to both of them, right? So this is the same segment. If the same segment is added to two congruent segments, then the sums are congruent. All right, so this was the addition property, so make sure you have that good vocabulary. And we are adding the same segment to the two congruent segments. All right, so again, that was just to make sure you really could nail down which of the theorems that you wanted to use, which of the properties. By the way, we call them properties because we can't really do a converse of the addition property. The converse of the addition property is the subtraction property. That's why we call them properties instead of theorems. It's just a little bit of a strange vocab for you, but in case you were wondering. All right, now this proof is going to be a little bit more involved. Again, you do have to remember and try and figure out which one of the properties you're going to be using, but there's going to be a little bit more to it, but I know that you guys can handle it. Why don't you see what you can do? Pause the video now and take a shot at it. Okay, so if I start looking at this, I have that angle, step 1 is angle ABC is a right angle given. Okay, step 2, EF is perpendicular to HF given. All right, and I am going to highlight those two in a lighter orange color just so that I don't forget EF perpendicular to HF. Okay. All right, I'm also given step 3 because I know a lot of you like to write the givens all down first. Angle DBC is congruent to angle HFG given. DBC congruent to angle HFG. All right, and now my goal, what I'm trying to prove is that angle ABD, this one here, is congruent to angle EFG, this one here. Now I highlighted it so I could see what I was going after, but I don't know that yet. My goal is to prove that. That's what I'm going after here. But as I see that, all right, let's see. Well, I know my highlighted ones are perpendicular, so maybe if I prove I have some right angles there, then I could use maybe some subtraction property since I will have the big angles congruent with my right angles and going to smaller angles. All right, I just made a plan in my head, so don't forget to make that plan. Okay, so my next step, step 4, is that I have to say that I have a right angle over here. Angle EFH is a right angle. All right, now this was because I knew that I had perpendicular lines, right? So we'll line up my if-thens. If two segments are perpendicular, then they form a right angle. Okay, so I've got my right angle. Now, if I want to use the subtraction property, I have to say that those big angles are congruent. Right now, I know that those big angles are right angles, right angle right angle. But I don't know that they're congruent yet. So I need a step saying that I have congruent angles. So step 5 is that those big angles, angle ABC, is congruent to angle EFH. So now my right angles are going to be congruent. Step 5, if two angles are right angles, then they are congruent. And again, I need to say that if two angles are right angles, not the same measure, because I didn't say anything about their angle measure, I have to use that correct theorem that if they are right angles. So watch your vocabulary there. Okay, so now I have these two big parts are congruent. I have the two little parts are congruent from my given. So now I can use the subtraction property. So here we go, step 6. Angle ABD is congruent to angle EFG. If, now let's see, is it the same angle that's being subtracted from two congruent angles? Ooh, nope, I have 1, 2, 3, 4 total. It's definitely two congruent angles being subtracted from two congruent angles, right? So if two congruent angles are subtracted from two congruent angles, then the differences are congruent. All right, so I'm definitely using the subtraction property, so make sure I've got that good vocabulary, and it was definitely a two congruent angles being subtracted on this one. Now, if you did that on your own and you didn't necessarily notice the subtraction property, but you went back to that complementary theorem we did in 2.4, you could have absolutely done that. You would have still needed to say that you have a right angle, but then in step 5, right here, instead of saying that the right angles were congruent, you could have said that you had complementary angles. ABD is complementary to DBC. And then you'd have another step saying EFG is complementary to HFG. And then your last step would not be the subtraction property, but instead, if two congruent angles are if two angles are complementary to two congruent angles, then they are congruent. And that would be okay, but it would be an additional step. So the subtraction property saved some time and some writing, and you guys will find out that you want to do that more and as much as you possibly can. So subtraction property was the fastest way to go here, but there was another way if you did it. Okay, so hopefully you're starting to see how we're going to use those properties, and now it's just practice, practice, practice. So when you're trying to apply those subtraction and addition properties, remember that if the segments or angles get bigger in the conclusion than the givens, it's addition. And if they get smaller in the conclusion than the givens, that's subtraction. And then be careful, are you adding or subtracting the same angle or segment or two congruent angles or segments? So all those things to just be careful of as you're doing your homework. Again, 2.5, I've got 3 problems for you. It doesn't seem like a lot, but they're really going to help you nail down if you know those theorems and when to use which one. And then a lot of additional practice. You know, if you're feeling shaky at all, give those extra practice ones a shot. As much as you can do those, the better off you'll be.